excited about this Khronos Group standard and about all the cool things we're doing with it. I'm Amanda Morgan. I'm the Senior Director of Open Standards here at Cesium. And this morning, I'm going to introduce to you Neil Trevett. He is a lot of things to a lot of people, but for today, here, what we care about is that he is the president of Khronos Group and the leader of our glTF work here at Khronos. So Neil, I'm going to turn it over to you.
Great. Hey, thanks everyone. Thanks for coming. So you are now officially hardcore, because this is a session where you get to directly interact with the glTF working group and the 3D tiles architects and have direct input into what we're doing, our roadmap, and how we're responding to your needs and requirements. So let me get up my other co-speakers up onto the stage. So Alexey and Sean, you want to join? So the way we're going to structure this session is we are going to have a short Q&A. I'm going to get everything in the right place here. Short Q&A, but then we're going to open it up to Q&A from the audience and some polls. We're going to be using Slido, so have your mobile phones ready. Because we want to gather as much input as we can. We also do have mics, though, if you prefer old school and you don't want to use the Slido. When you get to Q&A, put up your hands and we'll be glad to take your questions verbally on the microphones. So let me start. As Amanda said, my name's Neil Trevett, so my day job's at NVIDIA, but I am the Khronos president. We have Sean here from Cesium Bentley. Sean, do you want to briefly introduce? I know most people probably know you already, but in case they don't.
Yeah, so I'm Sean Lilley, a distinguished architect at Cesium/Bentley. I've worked a lot on 3D tiles and been involved in glTF also for just as long, since 2015 when I joined Cesium. So I'll be talking about glTF and the 3D tiles roadmap.
Cool. And Alexey, go ahead.
Hi, my name is Alexey Medvedev. I work for Meta. Actually, I'm doing air glasses, not connected to the geospatial per se. But I'm a chair of 3D format working group in Khronos. And basically, glTF is our, and KTX I will mention later today, that's our area of work.
Cool. So you have, I don't know if it's the right terminology, two horses' mouths right here. You're talking to one of the chief architects of 3D tiles and the chair of the 3D formats working group inside Khronos. Plus, we do have folks around the room who are members of Khronos, members of the 3D formats working group. That's the working group that manages glTF. Members of the working group, can you stand briefly, just so people know where you are? So we're going to be calling on these folks, when we need their expertise. So you have quite a lot of expertise throughout the room. So we're going to try our first Slido poll to get into the swing of things. So if you have a mobile phone, it's all confidential. You don't have to download anything. So if you want to scan that QR code and see if I can get my screen's in the right place, I should be able to bring up the poll itself. Oh my God, it worked. Okay, so juggling multiple screens here. So we just want to get a feel for who we have in the audience, and we want to see if the Slido works. So if you can go onto the poll, you should see a poll on your mobile phone screen. There's actually two tabs. There's a poll tab that will change as we do different polls throughout the session. And there's a Q&A tab, and that will be there the whole time. So at any point that you want to, type in a Q&A, and when we get through the slides quickly, we'll go into the Q&A session, and you can upvote the questions are already there too. So if you really like a question that's already in the list, upvote it, and we'll take those first. So let's see. Oh, it's working. Oh my God, it's working. So we have, not surprisingly, mainly developers, some creators, some business folks, and some others, and end users too, and educators. Excellent. Cool. Is it all working? Is it working for everyone who wants to use it? Any problems? Yeah? Okay, great. All right, let's see if I can find my slides again. So I'm gonna start with just a super quick overview of Khronos, just to level set everyone. In case you haven't come across us before directly, we're a non-profit, we're a standards organization creating royalty-free open standards. Our focus, every standards organization like OGC and Khronos, we all have our own focus and expertise. Khronos' expertise is low-level APIs for accessing GPUs and other hardware like XR hardware, doing AI acceleration, vision acceleration, and compute acceleration of various types. We have around 160 member companies, and membership is open to anyone who wants to join, and anyone here who's not a Khronos member would like to get directly involved is, of course, super welcome. We found that over the years we've managed to put together a sequence of APIs and file formats that are kind of great for spatial computing. We're actually working on a camera API at the front end called Camera. That's in development. We have a family of compute APIs. We have OpenXR, that some of you probably are aware of if you're doing XR development. We have the family of 3D APIs, WebGL, Vulkan now. We still have OpenGL and OpenGLES, Slang, which is a new shading language, and of course, glTF, which is the reason that we're here, the file format that's feeding all those 3D APIs, and the long forgotten, but not, well, sometimes ignored, but not forgotten KTX, which we're going to be covering briefly here because we think that's actually super relevant to this audience too. So we want to make sure that people are aware of the value that KTX can bring to geospatial. It's a container format for textures. So if you want to get engaged, as I say, the best way is to join, and there is a membership fee. That's the way we get to pay for what we do. We are a non-profit, and all the funds that we get through membership fees flows directly back into developing the standards. If you don't have the time or the money to get directly engaged, we have advisory panels, which are free, and for invited industry experts. If you want to join us there, we can get to see closer interaction with the working group. Let us know. But all of the specs that we do for glTF are actually developed in the open on GitHub. So you don't need to join or do anything. If you want to come and look at draft specs, you can go make comments for published specs. You can file bug fixes. You can engage with us pretty effectively on GitHub, and we try to, of course, do outreach meetings, including this one. So hopefully we're pretty accessible. Let us know if you're finding it difficult to get in touch with us. And we're pretty friendly, so it's fun to talk to us normally. So this is kind of the glTF-centric view of the universe. Of course, glTF being in the middle of everything. Our primary mission at glTF is to be a transmission format, optimized for runtime delivery of 3D assets. And I think glTF is to be, the working group is to be commended for sticking to that mission. We're resisting the temptation to become an authoring format. We're quite complementary, we think, to OpenUSD, which is trying to do something rather different to glTF and become an authoring format. They're coming from authoring movies. glTF is coming from delivering 3D assets on the web. So there's some overlap, but we'll see in a moment there's some good collaboration between glTF and USD. glTF has a bunch of tools. Most, or maybe all, are in open source for optimization and verification. Some are created by Khronos, some are created by third parties. We obviously want import and export out of all the key tools. Depending on the tool, the import-export capability it depends on the tool, how good the import-export capability. That's one of the inputs that we really would love to hear. If you guys are wanting to use tools out there for creating glTF and you're finding tooling problems, please let us know, because that's one of our main focuses, trying to make sure that tooling ecosystem is good. And increasingly, because we're going to have OpenUSD and glTF coexisting in the market, we want to have conversion between the two. And actually, a brief shout out to the Metaverse Standards Forum and the USD glTF Interoperability Working Group that has been chaired by Patrick, actually. It brings together both communities that potentially would be siloed if we didn't have the forum to bring folks together. The forum brings many kind of folks together. We have like 15 working groups encouraging cooperation and collaboration for creating the interoperability standards that we need for the metaverse. But this working group is focused specifically on making sure USD and glTF communities are talking together and collaborating together as we develop our individual roadmaps. We're doing it in a way that we're aligned, and we can, in the future, have seamless conversion between the two formats as we need. We're jointly trying to see if we can obviate the need for FBX going forward, which is costing a lot of money to support now, but there's still some gaps that FBX does that no one else does, so we're trying to figure out what bits OpenUSD should do, which bits glTF could do, and trying to figure out how we can help this round tripping between glTF and USD with collaboration, thoughtful spec work, and potentially test assets and test frameworks. Anyone's welcome to join the forum as well. So glTF, we call it the JPEG of 3D, just like JPEG. You can send a JPEG, I think, to pretty much anyone in the known universe, and they will be able to display it. That's kind of the mission of glTF, regardless of what their platform is. So this is a full-time job keeping this slide up to date. But we have the tools, the apps, the engines, the games, the asset stores, and of course, 3D tiles is down here at the Open Geospatial Consortium we work very closely with, but pretty much everywhere. And that of course, is the strength and the joy of glTF. glTF is also an ISO standard. It was made an ISO standard in 2022, and we're continually updating. We're pretty due for our next update to the ISO standard. And that makes it attractive as a baseline specification for various vertical markets. Of course, 3D tiles is the vertical geospatial that we're here talking about today, but there's also avatar formats. MPEG is using glTF for streaming 3D. The X3D standard from the Web3D Consortium is using glTF now, and glTF is even included in PDF because it's an ISO standard now. This is going to be the main topic, and Alexey and Sean are going to go into much more detail. This is how we see the synergy between 3D tiles and glTF working out. glTF, of course, is a broad specification intended for use by any market segment. 3D tiles has done such an awesome job in building glTF extensions that are servicing the needs of the geospatial community. We absolutely want that to continue. The glTF working group loves 3D tiles, and we see the value that 3D tiles is bringing to the industry. What we're seeing now is some of the functionality that's originally shipped in 3D tiles is becoming more broadly applicable. It's going mainstream, and so we're working together thoughtfully to figure out, does it make sense to bring some functionality that first shipped in 3D tiles, bring it back into the core glTF spec. If we do that, we want to do it in a way that's non-disruptive to anyone using 3D tiles, and that's what we're going to be talking about today. But I think this is indicative of a larger opportunity for the geospatial community. There are many markets out there that are beginning to figure out that the challenges that the geospatial market has been working to fix over the last few decades, like interactively streaming massive 4D data sets, these are no longer niche. They are about to go mainstream. And I think it's an opportunity and also some risk for the geospatial community. If the broader market doesn't realize that 3D tiles and glTF has already solved a lot of these problems and go out there and the rest of the industry reinvents the wheel again, it will be a lost opportunity and fragmentation that we would all want to avoid. This is an opportunity, I think, to get the broader industry to invest in the standards that we all need here in geospatial. So this session, again, is to get your feedback on how we plan to do this roadmap, convergence and ongoing evolution, and make sure that we're doing it the right way to meet your needs. So with that, let me hand over to Sean.
Okay.
Do you want to do it for now? You can come here, it's up to you.
Okay. Yeah, I don't have a clicker, so I guess.
Yeah. I think you can just do that, yeah.
All right. All right, so I'll be talking about the 3D tiles roadmap and especially how it relates to the glTF roadmap. So first, for anyone who's not familiar with 3D tiles, it's an open standard for streaming the built-in natural environment. It was released as an open specification in 2015. It became an OGC community standard in 2019, and we released 3D tiles 1.1 in 2023. And then since then, we've been working on a lot of new features for 3D tiles. This is like a selection of screenshots of different use cases that 3D tiles is used for. So we have 3D buildings, point clouds, photogrammetry models, vector data, voxels, instance tree models, and then just the overall global terrain and imagery. So 3D tiles consists of a tileset.json file, and this describes your spatial hierarchy. So it's how you subdivide your scene. These are often massive geospatial data sets, so it requires LODs and streaming to actually render this on a device. Each tile in the tree points to a glTF, so the glTF contains the tile's geometry, materials, textures, and metadata. And then using that information at runtime, you can apply styling, whether it's declarative styling or custom shaders or materials in Unreal Engine, for example. And so the ecosystems, the glTF ecosystem and the 3D tiles ecosystem are very tightly connected in the sense that all the things that are coming into glTF, we take advantage of right away in 3D tiles, given the fact that 3D tiles references glTF files. So for example, Draco and MeshOpt are really good geometry compression techniques that we leverage a lot. KTX2 is great for compressed textures. So especially for geospatial, we have a lot of texture data. So KTX2 is significantly less GPU memory than, for example, like JPEG or PNG. We also take advantage of GPU instancing. So this is for like instance trees and other objects. And increasingly starting to take advantage of PBR Next, especially in the AEC space where we want to have like concrete, like metal, like very physically accurate materials. And then we're starting to introduce new extensions to glTF that we've seen use cases in geospatial, so we're bringing those into glTF, and then those will automatically come for free, essentially, into 3D tiles. So this includes Gaussian splats, voxels, and AEC rendering techniques. So I'll go into a little more detail about each of these. So for Gaussian splats, we recently just, both on Cesium Ion and the glTF extension here, and in Cesium Jest, we've kind of done a big launch for Gaussian splats really at this DevCon. So Gaussian splats are a new technique for rendering radiance fields. Compared to meshes, it often captures thin geometry better. So that picture on the bottom right shows the difference between Gaussian splats versus meshes. We have the draft extension, KHR SPZ Gaussian splats compression. This is a glTF extension. It essentially extends glTF point clouds. So it adds additional attributes like the scale and rotation of the splats, as well as the spherical harmonics of the splats. And in collaboration with Niantic, we developed this extension. It uses SPZ for the compression aspect. And we have it running in Cesium Jest. And definitely welcome any feedback you have. It's an open pull request, so I think that's a link that you could click if you have access to the slides, but it's in the Khronos glTF repo. Another big thing we're working on is voxels, and we actually also recently opened the draft extension for this. There's a PR in the Khronos glTF repo. So it's called ext primitive voxels. This is the glTF component, and there's also a 3D tiles counterpart extension called 3D tiles content voxels. So voxels are really useful for, we talked about like subsurface data, or that was at the keynote this morning, but also for ocean data, like this ocean temperature data set of the Gulf of Mexico. And then we have a density plot of satellites that we're visualizing with voxels. And one thing that's unique about our voxel extension compared to some of the other formats is that we support a variety of shape types. So we support the typical box shape, but we also support cylinders, which are great for certain sensors. And then also we support ellipsoids. So this is really good, especially for geospatial data sets, like the ocean temperature data set there, or if you have weather data, it's a good shape type to use for that. And we support this in Cesium.js, and we also have a pull request in Cesium for Unreal that should be merged pretty soon, I think. So we've been working a lot on voxels. It's actually been a multi-year effort, but we're starting to actually bring it into glTF and then have that be brought into 3D tiles. And then in the architecture, engineering, and construction space, we have several extensions that are in progress. So the first of these is primitive restart. This is kind of just a generic extension for being able to render polylines more efficiently, especially if you have a lot of polylines. But it's not just an AEC specific feature, it could be used for other use cases. And then another extension is edge outlines. So kind of like the picture here, being able to draw outlines around geometry. And then on the roadmap, we have several other features planned. So for example, billboards or view independent geometry, polyline materials, so things like dashed lines or line thickness, and then the ability to control point size in glTF, and then a few other features. And if you're interested in seeing more, there's a link to a GitHub issue that describes all of the things that we have planned. So back to this slide, just showing how everything that's going to the glTF ecosystem kind of automatically gets included in the 3D tiles ecosystem. But I also wanted to show sort of what we've been talking about recently, which is maybe like the reverse path, where a lot of the features that are general purpose inside 3D tiles could make their way back into glTF. And I guess Alexey will talk more about this, but we have this new format that we're looking into called glX, which is sort of not necessarily an extension of glTF, a new format, but it includes almost all the same concepts of glTF, very similar schema. And it's meant for complex scenes. So the concepts of 3D tiles that are relevant to complex scenes, like spatial subdivision, level of detail, and external glTF references, we kind of want to take those concepts from 3D tiles and start to bring them into the glTF community, where we think they'll have broad applicability. And this is just one potential sort of view of what this might look like. And we want to also be sure to have like backwards compatibility with existing 3D tiles and glTF. So this is just a concept, but one idea is really 3D tiles would have, well, actually I should start on the glTF side. So the glTF side would be the asset itself, the geometry, materials, textures, metadata, interactivity. And then glX would be the complex scenes, which would be the spatial subdivision, the level of detail, et cetera. And then those would be the sort of general purpose concepts. And then 3D tiles would wrap around that. It would introduce the geospatial concepts. So this would include kind of like bounding volume types that are specific to the geospatial space, like WGS84 regions or the S2 tiling scheme. And then some metadata about your coordinate reference system, or like what ellipsoid that your data is referenced to. And potentially more geospatial specific features like vector data. So those would stay on the 3D tiles level, but everything general purpose would either move into the glX level or the glTF level. So this is, one potential view of what it might look like in the future, and we're still definitely in the early stage of defining what this might look like. So I think with that, I'll hand it over to Alexey.
Thank you, Sean.
Yep.
So whilst Alexey's coming up, again, for those of you just joined, or those of you forgot, we're running a Q&A interactively on Slido. So grab the QR code now. Get it on your phone. The Q&A tab is up there permanently. Put in your questions as you're listening to the presentations. Thanks, Alexey.
Where's the Neil? How to switch over to the presentation back? I need the presentation back.
No, you just do that.
Okay. So, hey, I will deep dive into our plans, future plans, but meantime, I'll just do a quick refresher what kind of capabilities glTF has today. We'll start with PBR materials. I think that's one of the key feature of glTF. It's the way how glTF describe the material properties kind of proved to be like a long-standing future approach. I started with basically one chosen model, which is material model, which is metallic roughness. And since then, because the model itself represents only some amount of materials, real world materials, the idea is just introduce additional extensions that will add more capabilities for the more visual richness for the materials. So this is our roadmap. As you can see, almost every year we release some extensions that improve the amount of materials that can be represented by glTF. And again, that's one of the beauties of glTF PBR. It doesn't require to change anything. So you can improve your shaders, you can improve your engines, etc. It will not touch the actual assets. You can reuse the same asset, but just render it with the higher fidelity. It's really up to you. And we have a long roadmap, again, that's a really visual rich materials are incoming. As today, the subsurface and diffuse transmissions are in discussions. They will represent a human skin or something, really complex materials. One of the missing feature for this sort of preset glTF PBR material is a lack of flexibility. We just define the properties of materials, and that's it. Sometimes you need the way that you can do some adjustments, like detail maps or whatever, the new features that base model cannot guarantee. That's why we work on the procedural textures, the extension that will describe the actual shader graph, sort of shader graph for the material that you can specify your detailed information. It's fully compatible with the actual PBR material. That means you can customize the inputs for the material properties, but it's up to you, again, how you can control this. And in conjunction with the interactivity, etc., you can just build really visual rich and even interactive materials in the future if you want. KTX is a texture format. Somehow it belongs to 3D formats, but again, it's a texture. That's one of the missing, let's say, for the missing features in general for any sort of image formats we have today. That's almost non-existent container formats. For example, if you have asset that has all the texture maps for your material, there is no JPEG or whatever the file that you can combine into single asset. For example, if you need effectively stream this, or you need MIP maps. KTX sort of solved this problem for you. This is container format that allows you to store different types of images and formats of images inside it and be super efficient for the actual streaming. Again, you can store the MIP maps, you can store different types of textures, including the actual compressed textures in this. And helps you as the content creator or user, again, to mitigate the problems with huge variety of different hardware that you need to decompose. For this specific one, we have the universal GPU compressed architecture format. That means you can transcode into intermediate representation and then decode on your specific device. So that means you don't need to keep the each texture for each individual device, such as Android phones and like iOS phones or web or whatever. So you can just like literally use the same texture and then decompress and fly. Super efficient and super fast. So it's designed to be friendly for the most GPU-friendly compressed formats. And again, it allows you to store the data in one container format, which is really important for the content management systems. This is our spatial computing idea. So we picture glTF as the future format for some sort of smart assets. Like traditionally, you think about glTF, it's pretty much static. So that means you have the geometry, you have some sort of materials in this, animations. This was the most interactive part of this, but that was not enough. Yeah, so we're kind of moving to the way that we want to exchange the assets, and the asset now has the actual properties that can be met from the actual real world. And I think that's our way to do this. We have several directions in general. So we have the interactivity, we have physics, complex scenes, and audio. I will talk about them like in the next slide, but again, that's a whole vision actually. We are moving into sort of self-contained objects that can represent multiple properties for the future usage. Let's start with interactivity. It's our portable way to represent the actual scripting system for the assets. If you're familiar with Unity visual scripting or Unreal blueprints or NVIDIA Omniverse action graph, you can probably map this to what we're trying to achieve. It has some restrictions, but by the end of the day, it's the actual node graph, fully Turing complete. Again, so with some limitation that allows you to address the content of the glTF files and do really complex logic. So this video that plays on the slide, actually just like the asset. I think that's a part of the beauty of this idea. It's like you create and embed the logic into the asset, you distribute across different layers, different engines. You'll see the same result, not only visually, but actually the logic behind this. Let's assume you have a building, you have a door, and you want to open the door when you like pushing the knob. So you can embed in your asset, and you'll see it everywhere, in the web, on mobile, and any sort of the engine that supports glTF. Along the way with interactivity, again, which is spec, which is ready, please go to GitHub. You can implement it today. It's almost complete. We're super close to ratification for this. We had to create the additional extensions, which is kind of satellites, and create this constellation of the extensions. If you want to interact with the actual objects, you have to be able to understand, oh, what I need to do. If you like a point into this button, should it hover, should be visible, should be selectable, etc. You name it. So we kind of created a bunch of extensions to make it friendlier to actually interact with the properties of the glTF object. Another smart extension is physics. Traditionally, glTF supports only animations or morphing, which means it's pretty much pre-baked for you. But the most complex animations just require a lot of work and effort, and it's hard to kind of predict how it will behave like in all the possible permutations when they interact with something else. In physics, it's kind of traditional way for many software, including like games or interactive ones, just like use the physics engine to create this animation of the actual properties. We have two extensions work today. One is implicit shapes, which actually allows you to create just definition of the actual shape, such as box, sphere, etc. You name it. It's like pretty much mathematical approach without the actual description of geometry in it. It can be super useful for collision detections or any sort of applications. Again, everything works in conjunction with interactivity and other extensions. And the second one, it's the actual physics rigid bodies, which encapsulates the motions, materials, joints, filters, all this kind of typical for the physics engine properties. And the extension itself, it's physics engine agnostic. So we're trying to be friendly for the most popular physics engines on the market. And I assume they will be super easy to integrate with existing solutions. The next one is audiograph. That's the way to create the sound and audio rich, again, sort of experience for the glTF assets. As today, we have no ratified audio extension, and we have several vendor ones, and we have another one which is audio emitter, just define, oh, this is sound, I want to play this. But we see use cases when the people want to create, again, some sort of complex audio processing. This is our approach to make it happen. Modernize as anything else. We use acyclic graphs everywhere, as you can see, procedural textures, interactivity, audio graph, it's not exception. You create the graph, you connect the nodes, and you have all the kind of full processing for the audio if you want to. So the concepts, we have the audio nodes as the source and the emitters, and then we have different kind of audio processors, and then it's aligned with web audio standard. Again, I think it makes like easier to adopt for the future. Gaussian splits, Sean already explained the current approach. For our working group, idea is we're trying to gather as much information from different companies as possible, and we're trying to generalize and make this super generic. Gaussian splits sounds really interesting direction, but along the way we feel like it's actually a good idea to improve the glTF ecosystem along the way. If you dissect the problems that the Gaussian splat extension trying to solve, actually it gives us like really great pointer of what we can do on the level like, oh, probably we can change the way how we address the internals of glTF file and so on. So kind of the idea is we get the use case and dissect to the different levels of extension that can be useful in sort of like different situations. And Gaussian split, it's one of the examples. You can use the mashup or other extensions to make it happen. You can use the way how you address the internals, glTF files, etc. So we're trying to align across all the levels that represented here. It's a really great exercise for us to make it right. GLX is a next big thing for us. It's in discussions for about like maybe 2 years already, but we finally decided this is final name, so it's GLX. One of the fundamental missing feature of glTF is ability to reference the another files. And again, we had a lot of discussions, and we finally decided that should be the separate file type, because it's super close by JSON schema. That's based on the similar approaches, but the reason is we want to address way more complex scenarios in general. It's not like only complex scenes. We want to address the shared environments. We want to address the shared lighting conditions. We want to address the referencing on non-glTF resources. We want to address the different way how we can represent the scene hierarchy and spatial subdivision for this. And it's too much to put into glTF. It's already kind of really fat format in sort of extensions and capabilities. And it's why we feel like, oh, GLX, actually, it's a fresh start. We can do way better if just like move this way. But 3D tiles has a lot of capabilities which is super close to what we're trying to achieve. That's how we came with this idea that probably will uplift 3D tiles features and make them super generic. Again, as I mentioned, spatial subdivisions, LODs, structured metadata, everything is super useful, not only for geospatial, but for all 3D industry in general. And that's where way we are going. Details to be announced. It's in discussions, but decision being made. And this is discussion. Again, it's pretty much repeats previous slides, but 3D tiles use a bunch of glTF features, introduce new amazing features. We're trying to adopt them, bring back into glTF ecosystem, and it's kind of this closed circle that we kind of benefit of each other all the time. And I think it's pretty much generic approach for our working group in general. If we see something super common, we uplift it to be a generic extension. And that's our way to go. This red lower left statement, super important. All updates would be backward compatible with 3D tiles. We're not breaking nothing. So basically, we are not breaking glTF ecosystem. We're not breaking 3D tiles ecosystem. Everything feature-wise and compatible will be stays for a long time, maybe forever. And this is our roadmap. As usual, optimistic, but it gives you the idea of what we are working on. And yeah, our future is all the extensions I mentioned before, and I think our primary focus would be mostly GLX for the next year. And I think that's the time for Q&A.
Yep, cool. Thank you, Alexey. So let's see how we're doing on the Q&A. Let's see if I can figure out how to do that. So that was our previous poll. Okay. Yeah, great. Okay. All right. So, and these are upvoted. So again, reminder, if you haven't done it already, you can go onto the Slido, you can add new questions, you can upvote the ones that are already there. So let's start at the top. Are there any proposals to standardize the styling of tile sets? So.
Yeah, actually in 3D Tiles 1.0, the declarative styling language is included in the spec, so that is one way to style tile sets that's already part of the specification.
Okay, that was easy.
Could we ask maybe other use cases people have for styling?
Sure.
Yeah, I guess, custom shaders would be one other example of something that hasn't been formally specified. Same with using Unreal system for materials. But yeah, I'm curious what other maybe use cases whoever asked that might have.
I ask in part on behalf of Bert Tome from SojLink, who was presenting on his use case for converting PostGIS to 3D tiles, and he wants to style them in both Cesium.js and 3JS. And he was under the impression that there's not a uniform description of the styling. You know, Cesium.js has its styling language. He was under the impression that that was not standardized and he couldn't implement it also in 3JS. So that's incorrect?
Yeah, it is standardized, so it could be implemented in 3JS.
All right.
Yep. Yeah, not currently. That might be that would possibly be a good contribution to the 3D Tiles renderer plugin in 3JS.
Yeah, and thank you for coming up. Please feel free to come up as we're having the discussion around any of these questions. Come up to the mics and join in. So next, any plans to support procedural or parametric content generation in glTF? Alexey, maybe?
I'll probably take it. Yeah. Well, yes and no. First of all, I think with interactivity and implicit shapes, you can do some procedural parametric generation today. But in general, we discussed this many times. I'm not sure if we kind of agree that we need to go in this direction. Just because we want to, again, maintain our ecosystem in the healthy state. And usually when you start to discuss this thing, it opens the Pandora box, how exactly you have to behave on different platforms and support different features. So I think even maybe it will be like super controllable for the super specific cases that we kind of 100% sure it will not break anything. As I mentioned already, so we have implicit shapes. That's exactly procedural description for really basic geometry. And again, interactivity allows you to control almost all the properties of existed glTF asset. It will not generate new, but you can adjust if you want to.
So we've been talking about subdivision services, right? And
yeah, subdivision services is part of this, but that's exactly the reason why we're still not discussing this seriously. So it's many questions. Well, no, we're discussing this seriously. That was wrong statement, but we have not decided anything yet. If it's specifically about NURBS, yes, that would be only possible supported for the nearest future.
Do the AEC extensions include any implicit shapes? It's actually a question, I don't know.
Yeah, the current extensions don't include implicit shapes. We are in some ways leveraging the existing KHR implicit shapes extension. But yeah, we have plans to have future extensions that might support NURBS or B-splines or other things.
Okay.
Yeah.
Okay. So next up, are there any efforts to make KTX easier to integrate with applications? Current problems include Git LFS, broken dependencies in VK package.
Okay. I assume the answer is yes, but if you don't know about the problem, we don't know about the problem. If it's something like super specific, please reach us out today or like later on GitHub, and yeah, we'll take care about that, because the problem sounds like super real life kind of pain problem.
Yeah, this has affected us on the Cesium team early because we use we use KTX2 inside Cesium native,
Okay.
or like the KTX2 library. So I think this specific issue about VCPKG may have been fixed already, or at least people are aware of it and attempting to fix it. So
We have Leonard here, and this is the most proper person to handle this problem.
Okay, so thank you for those of, we have a poll. Let's do a quick poll. This is kind of a generic one. It's not too late. Poll is still open. Interesting to see what is piquing people's interest. So Adam, looks like good news. Looks like Gaussian splats is coming out on top, perhaps not surprising. And GLX, of course, maybe that's not surprising either. Oh, Ed, PBR, woohoo! PBR is coming out pretty high as well. Voxels, okay. I'll keep that poll open a little bit longer if I can. I think I figured out the UI here. It's like piloting a 747, but cool. Please do go into the poll and cast your votes for a few more minutes. Let's go back to the Q&A, if I can. Down here, okay, show Q&A. Yep, glTF questions come to the flight simulation industry. Yeah, please, go ahead. We have a list. Yep.
First question, since your guys' roadmap changed my questions a little bit.
Can you just make sure you speak into the mic?
Is it on?
Yeah, it is. You might just have to
Testing. Okay.
Okay, much better. Yeah.
Your guys' roadmaps changed my questions a little bit. So first, is GLX going to be a super sample or superset of glTF? Example of could you contain geometry and mesh? No.
No, it's not superset. Actually, that's even not subset. It's closed by JSON schema, but it's different.
Okay, then more specific, is the external reference going to be put into glTF at all?
No. So all the external reference will be part of GLX, and you can refer the assets, but you cannot store materials or geometry properties inside GLX.
Then I guess this will be for 3D tiles. Will the lower level glTF GLB file be will the GLX be a suitable extension for that low level content?
GLX, yeah, basically you can define the spatial information as nodes, transformation, and then embed assets into this, refer assets from this.
Okay. So that takes care of that. But
Did that make sense, by the way? Does that
I
make
think
sense?
so. I have to ask one random comment. Please do some kind of vector data that isn't text. So binary.
Yeah.
Then the two that are coming from the flight simulation portion is I'm pretty sure anybody that has to deal with flight simulation has to deal with OpenFlight. And there's a couple things that I've been told by our modelers in-house that they do differently and painful, mainly of switches and LODs. I'm curious what your guys' LODs are going to be, because it's already fracturing. I've seen two extensions, one from Microsoft and one from, they did it like yesterday, of Geo something, where it was like, they're coming from OpenFlight. So mainly if you have an LOD, have options for distance and not pixel space, because that's been a pain for us when we do pixel space because of different screen sizes.
Actually, that should be normalized by the screen coverage. Should be agnostic for the actual screen resolution.
Yeah, but so a 0.1 pixel size for a 2K versus a 4K versus an 8K, whereas we need to have it show up 500 meters and stay at 500 meters, but if you get a much larger display where the pixel size goes away, it goes away.
I see.
And so we don't want to have multiple models for different screen resolutions.
Yeah, makes sense. Sure, it's a good input. Yeah.
If you want, I could go into detail on switches, but
We'd love to have that conversation with you, totally.
It sounds like switches could be served by the interactivity extension, potentially.
I don't know. I have ideas of how it could be, at least to make someone's life easier from OpenFlight to glTF. I'd have to see what the interactivity stuff would be.
Yeah. Leonard, are you taking notes? Yeah, great. We will.
I think
Yeah, let's have a
I've already
follow-up.
got something from the Cesium, and I think it's one of you guys that was going to have another conversation, but
Yeah.
Okay.
But I think, hopefully this is an opportunity to fight back against some of the fragmentation. So if we all work together and we get your requirements.
Okay.
Yeah. Thank you for the questions. So next up, might some geospatial aspects of 3D tiles be defined as GLX extensions? So a tile set using geospatial bounding volumes could express structure in GLX.
So this could be the case. So, if for example, the region bounding volumes or the S2 bounding volumes, I could see those making their way into GLX potentially. So if GLX has spatial subdivision, you might want the geospatial subdivision as well as an extension.
Okay, so I've just kicked off another poll. We'll do it in parallel whilst we're doing the Q&A. Okay. Are we going to 11, right? Interested in what the biggest challenges are for glTF and 3D tiles? No, please. And if you have an other, just type in a question saying, this is a statement, not a question. My problem is, and we would love that specific feedback.
We can optimistically combine documentation, samples, and tests in one sentence. It's like we program it for success by default by this.
Yep, yep. Okay, so the poll will be open. Please go and check that out. Let's see, next upvoted question. Might some geospatial aspects of 3D tiles be defined as oh, we did that one already. I'll tick it off in a moment. How do we balance pushing too much engine-level logic into the format without breaking portability? Yes, thank you, Tam. Great question. You wouldn't believe how much time we spent talking about that. Alexey, go ahead.
We talk a lot. That's exactly how we balance this. It's like a battles almost every working group call about, is it runtime, not runtime, what can be part of spec. I don't think we have any recipe, the consistent one. No, I mean, it's one of the questions we ask all the time, like, is it too much or not too much? We try to stay friendly, and the goal is, again, not break our ecosystem that we have today. And if you feel it requires additional effort, significant additional effort for some runtimes to make it happen, so we kind of trying to not go this way.
It'd be really great once people try it to see whether we have in fact got the balance right. But a lot of people put a lot of thought into it. So, and the first people that have used the first implementations, I think the feedback is positive, that we're close to a sweet point where it's not too complicated, but it is useful. You can't do AAA games in it, but no, you can do gamelets. That's the kind of the target. Okay, next one, PBR question. So, Ed, you might want to come up. Let's see. Materials including PBR focus on human visualization, RGB only. Are there plans to address spectral materials? Yes, this came up yesterday. Many wavelengths other than via an extension.
Yeah, hi, my name's Ed. I'm the chair of the PBR group for Khronos. And our group, yes, it is focused on just visual appearance of the material. Our PBR definition is set up that way. And certainly I've heard a lot of interest in spectral rendering, and I think the way this question was worded was a little interesting. Is there any way to do it without an extension? No, an extension is absolutely the correct way to implement something like this. It will probably not be handled by our PBR group, at least in the short term. It's not something that the group of people that we have on that particular call is focused on, but I know there are other people who are not on that call who are very interested, including some at the company that I work for. So it is quite possible that we could see an extension show up someday. One thing I will say about extensions is they work best when they have a champion, when they have a subject matter expert who is very interested in promoting and championing the extension and can, write the draft of it and explain what all the parameters are in it and why each parameter is needed. And then we bring that to the main Khronos 3D formats working group, and we say, this is our extension, these are the parameters. And if I can, I saw another question flash by earlier. Do you require a conformance test and a sample implementation? Yes. Before it goes into ratification, an extension typically requires at least 2 sample implementations, ideally from different vendors. And that's how we know that the extension is broad enough that it's not just one company's way of doing it. It is something that can be standardized across multiple implementations. So yes, a conformance, a test model, a sample implementation, these would all be great things to have for any extension, including this specular wavelength type of rendering extension. So.
Yeah, so thank you, Ed. So let's get specific, though. I mean, this is a good example, for other functionality that people want to. If you have a champion here who wants to take the initiative, What should they do?
They should look on GitHub for the extension that is most similar to the extension that they want to write, and copy and paste all of it, and then change the text to be what they want it to be. and then submit it as a pull request back to the glTF repository on GitHub. You should also, of course, join Khronos. Haha, Neil, I got there before you. Hey, everyone join Khronos. If you join Khronos, that helps out with intellectual property rights. It shows that the legality of supplying that technology to Khronos and making it an open standard is going to be good across the board. glTF is open thanks to Patrick Cozy, who championed that many a year ago, and so we do accept pull requests from the public, and they can be vendor extensions, they can be multi-vendor extensions with that ext prefix, or they can be intended to go through the full Khronos ratification with that KHR prefix on the front.
Yep. Thank you, Ed. Yes, so you don't need to be a Khronos member. Get that pull request in, and if you need help, reach out on GitHub, and the working group will be glad to help you. And join in if you want to get more deeply involved and have the direct conversations. So let's see how we're doing on the poll. Let's see. Oh, wait. We'll do one more question once I figure that out. I have to turn on things. How will GLX differ from glTF today? And will GLX be usable directly in Cesium.js? That's a good question.
I mean, I think as we're working on it, we'd like to start implementing it in Cesium.js just to prove it out. So it'll probably be an iterative process. I don't know. Yeah, there'll be some differences, but I think it'll tie, at least when I think of Cesium.js, I think GLX will probably tie into the 3D tiles rendering system in some way. So, but a little early to say, but we would definitely start experimenting in Cesium.js.
Okay, let's try this one more time. Yes, okay. So what are the biggest challenges? This is very interesting. Material and texture limitations. Okay, that's a surprise. Does anyone have any? Does anyone want to come up to the mic and give us more details if they have something specific? Feel free if you do. Missing features. Okay. Okay, this is cool. We're going to take all this data back to the working group, and this will be excellent input and food for thought. So let's keep going with the queue. We have like 15 minutes left. Where is the embedding of various immersive spatial volumetric video formats in the roadmap for transport streaming LOD in GLX, glTF? Any thoughts on that? That's an interesting question.
Yeah, I mean, I could talk about the voxel side, which I think could be a little different from volumetric video, similar but different. I mean, for voxels, at least our plan is to bring that into glTF as an extension, and then the 3D tiles layer would be the LODs of those individual glTFs that would represent just pieces of the whole voxel data set. But yeah, volumetric video is different. I don't know enough about that to say.
Okay. Next, Mike. Oh.
Before that question goes away, I'd like to know more about actually embedding the video into glTF for transport. So when a scene is downloaded in 3D using glTF, can it just the same way that you're planning to embed audio, bring in video?
We have some video extensions. So we have the video texture extension. It's probably specific for for specific video formats, but I see no problem to extend it for the spatial one as well. But if it can be represented again as the input for the actual PBR material, that should be fine. Maybe not. Again, spatial is maybe complex. As long as as long as it goes this way, that's doable. For the, if we need to connect to the actual voxels, etc.
Go ahead.
The context of the question is more, so you have a stereo video that not necessarily have a volume to it, but if it's a volumetric video, it would. But you're able to perceive it in stereo, whether it's billboarded or whether it's positioned. That's really the, because there's such a wide variety of codecs from so many different vendors, formats that we haven't even seen come out yet, just adapting an extension to say, okay, well, this is using this codec, and we now support this vendor extension to bring in that format into the scene for consumption at whatever perspective the user or users are enjoying it in.
It's only part of the story, unfortunately. So the other part, again, how you want to combine with actual glTF, because glTF itself, it's some sort of geometry plus materials, and materials might have the textures as input. So like if you think about how you want to represent this, it should be either something inside the glTF that creates the actual appearance of the 3D shape or like 2D shape to render, right? So this is glTF is about, represent geometry plus material. And if you want to feed in the video as input for this data, again, we have this video texture extension in development today. And if it's like we are talking only about like, oh, we need like separate for stereo for each eye or something, that probably can be part of this video, maybe just additional on top of this extension. But again, glTF is slightly more complex than just, oh, we need to provide the data. It should be connection to internals.
Okay, we can talk more. Let's get through as many of these questions as we can. Thank you everyone for putting the questions in. Might some, oh really? Okay, that first one was? Okay. Are there efforts to make KTX easier? Did we?
No.
Right. Good. Good. Okay. Okay. How does the glTF ecosystem test for valid operation of import and export from tools?
We have tools to test the actual assets. And I assume you can use the tool to validate the results of import or export. I think it's a sort of tricky question because we are not control either importing or exporting. We just provide the spec and we provide the tools for you to make sure you can use this. So that I think it's up to the actual software to do the checks. And
the tool's name is the glTF validator.
Yes, that's
and
correct.
It's on the website. There's a web-based version. You can drag and drop a glTF onto the validator on the web, or you can download a command line version for use on, I think, Windows and Linux, and I forget if there's a Mac version or not. I don't recall off the top of my head. It does? Okay, there is Mac. So the validator will sort of go through any glTF file and check all the rules, all the little edge cases that we've come across before. So whenever you write your own, homemade glTF exporter, we always encourage you to immediately run the results through the validator and make sure they're good. And then for testing importers, we have a whole collection of sample assets. Look for the glTF sample assets repository from Khronos on GitHub, and try importing all the sample assets that you see there. And they test all sorts of edge cases and sparse accessors and funky uses of texture maps and all sorts of weird things that you might come across. So that's sort of the different strategies for you test the exporters by running the output through the validator, and you test importers with our sample assets.
Yeah, thank you, Ed.
I might add, so those kind of checks, they're pretty much mechanical against the JSON schema, and it's not checking the content. We have actually another tool, which is glTF asset. I forgot the name. Asset auditor. Yes, Mike kind of involved. And basically, you can specify your requirements, specific requirements for the asset, like the amount of geometry, some properties for materials, etc. You name it. So it's like and in this case, you can actually check the content of your file as well, not only schema. Sorry?
Mike, I can't hear you.
Also, if you have a glTF that you're not sure that's working, glTF translate or Don McCurdy's tool.
Yes.
I think that's the correct.
glTF transform.
Yeah, transform. Thank you. Is a really, really great tool to use. So, and it has the glTF validator built in.
Yep.
Yeah. And as we were mentioning on the panel yesterday, making sure that tools work, using all the test assets and all the different ways of making sure import and export tools is so important. It's like central to the integrity of the ecosystem. So it's something that we really stress. So there's an ongoing poll about KTX. Glad to see that people are using it or not, or planning to use it. But if you're interested in KTX, please put your opinions in there in the poll. Let's get back to the Q&A. Is there any work to allow easy property metadata to connect between glTF tiles and even from USD versus having to be converted or transformed coming from AEC?
So they might be encoded slightly differently, but we're hoping that between USD, glTF, and other formats that they would at least share the same data model and they could point to the same data model. But whether the metadata is encoded in like as strings or as text or as binary, I think is up to the format itself. Like for glTF, we have a structural metadata extension that encodes it in binary, but for USD, it might be in text, but hopefully the data model would be the same between them.
Okay, yeah, go ahead.
Yeah. This is me. I work for an architecture firm, but I'm involved with IFC work as well. So we have this problem that our data is highly graphed. And so like keeping track of all the sort of changes in formats and making sure the relationships are always there is super problematic, let's say. So this is an area that if there was work, I'd be very interested to help connect groups of people that are working on it. So
cool.
Yeah.
Let's chat after and
perfect.
Connect. Yeah. Yeah. And anyone who'd like to stay connected and continue the discussions, please come on up and drop us your contact information. We'd love to stay in touch. All right, let's see. 6 minutes, 1, 2, and 7 questions. Have you considered encouraging conformance tests or some implementations? Well, we kind of talked about that one, right? Is that one?
No, it's not. Well, yes.
Okay.
Some of them are really hard to actually do the tests. Like anything that related to PBR, for example, and materials might vary, and that's the idea of PBR in the nutshell, actually, to be able to render with a different visual fidelity. So some features, it's really not easy to test, let's say, but some of them, as interactivity, should be fully, completely tested. And yes, we are working on the test suite, including the actual generated tests to stress test this functionality. So yes, it's incoming. We cannot require, we try to encourage. And I think that's the way for us to go, yeah, just be more friendly.
Okay. How robust will converting between USD and glTF be?
We have a plan to support some amount of features. I think it's pretty much specific, actually. Like the Adobe has the Adobe file format project, which do USD and glTF conversion. And if you check the current work in progress statement and the future plans, I think that would be the baseline, what we want to guarantee between glTF and USD interop.
I mean, obviously, USD is a lot more complex than glTF by design, and that's why they're complementary. glTF, its beauty is its simplicity, and USD, its beauty is its power and flexibility. So you can't take everything from a USD file and put it all into glTF. It doesn't make any sense. But what we do want to work with, and we're working at the Metaverse Standards Forum in the USD glTF interoperability group, is the stuff that does make sense to take between the two. It is painless and seamless. It's not totally painless and seamless at this point. There are things like some animation stuff that isn't supported in USD that glTF has, and there's some things in the opposite direction. So there's some short-term friction points that we need to figure out, but longer term, the goal is, because we have the two communities talking together, we can avoid those inadvertent mismatches in functionality. So hopefully USD would be a proper subset in many ways of glTF to enable that translation to happen. And that working group is open to anyone who wants to join the forum. There's lots of cool people there working through that problem on a weekly or bi-weekly basis. Let's see, 2 minutes. We have one last question, and it was upvoted. So, how will the metadata from 3D tiles be folded into glTF?
Yeah, so we have, there's an extension in glTF called ext structural metadata, and then there's also an extension, ext mesh features, which allows you to define features on the geometry that point to the metadata. So yeah, there is already an extension, and so the 3D tiles metadata and glTF metadata are kind of very similar. And yeah, so it sort of already exists. And yeah, let us know how it seems if you try it out.
Okay, cool. All right, so we're out of time. Thank you all for the questions. So we're going to save all the questions, even these last few that we didn't get to, we'll take them into the working group. So thank you all for your input. Can I do a quick show of hands for real? Was the Slido good? Was it good for people? Yeah, okay. All right, cool. All right, great, thanks. All right.
Thank you so much, Neil, Sean, Alexey, for this very informative and interactive thing. So can we just give these guys another round of applause?